Hi, I'm Lauren, and the problem I'm going to be doing is number 28. A roller coaster vehicle has a mass of 50 kilograms when fully loaded with passengers. A. If the vehicle has a speed of 20 meters per second at point A, what is the force of the track on the vehicle at this point? B. What is the maximum speed the vehicle can have at point B in order for the gravity to hold it on the track? So they give you a diagram here, but I separated it out into event A and event B because they're independent from one another. So if we look at the free body diagram for event A, we know that the radius is 10 meters, the speed is 20 meters per second, and the mass is 500 kilograms. And we know that the position of the cart or the car is at the bottom of the track, which means that there are two forces acting on it. There is the normal force and there is the weight of the car. The weight of the car is pushing down on the track, which in turn pushes up with the normal force. So since the question is asking us at what force does it push up, we're finding the normal force. And using Newton's laws, we know we're trying to find the sum of the forces in the y direction equals mass times the centripetal acceleration. Here we know that it's the normal force minus the weight because we know it has to be a positive number because both mass and acceleration, they're going to combine to be a positive number. And so because there's centripetal acceleration towards the middle, the normal force has to be larger than the weight, or else it wouldn't be positive, it would be negative. So let's just say the weight was larger, then that would be a smaller number minus a bigger number, which would be negative. So we know that it's the normal force minus the weight. It's bigger minus smaller, equals mass times acceleration. So what I did was I first solved in variables. So I moved the mg to the other side, I condensed it, and so the normal force equals the mass times the quantity of the gravity plus the velocity squared over the radius. So we know all of those numbers, and I just solved for it. I plugged it in, and I got that the normal force that the roller coaster itself is pushing back up on the cart is 24,900 newtons. So that's the answer to A. So now going on to B. B, we're asked to solve for the maximum speed the vehicle can have at point B in order for the gravity to hold it on the track. This means that it's at the top, and just gravity is holding it down. So if we wanted to do, again, the sum of the forces in the y direction in order to figure out the maximum speed, we're going to use the same equation that we kind of used at the top, which is the sum of the forces equals mass times centripetal acceleration. But trying to figure out how the forces work out is a bit tricky. So I drew the forces here. There's a normal force that's going, or supposedly, there should be a normal force that's going up, that's pushing back on the cart, and the cart is pushing down on the track because of the weight. However, if we see here, we want the gravity to be maximized. So we want the force of gravity to be maximized because we want that speed to be the largest. So what's happening here is that if we had normal force, any normal force at all, it would be mg minus the normal force, because this would be down in the center of centripetal acceleration. So we would do bigger, which would be this, minus the smaller, which would be this, equals mass times acceleration. But if you move it to the other side, you figure out that the larger that the normal force is, the smaller that your mass or your weight is going to be. So these, ideally, if you want this to be the largest, if you want the gravitational force to be the largest, n would be 0. So in this case, in order for the maximum speed of the vehicle, and so we don't have any normal force pushing up, we just have this force down, that means that the normal force is 0, meaning that it's at this point where the cart is like kind of suspended over the track, meaning like it's going so fast that the only force that's pushing down upon it is gravity, because it's like suspended in the air for a second right at the top. So armed with that, we know that the sum of the forces is just going to be mg, equals the mass times the centripetal acceleration. We can cancel out the masses, and we know that gravity equals velocity squared over r. We know all of these factors. I isolated v because that's what we're solving for. We know the square root of g times r. G is 9.8 meters per second squared, and the r is 15 meters. That's the radius they give you. So in the end, the maximum speed is 12.12 meters per second.